Okay, up until this point, we've talked about different techniques for solving quadratics, okay? We covered solving by factoring pretty early in the year, and we talked about a few steps, right? Step number one was always to set the equation equal to 0. Because there was an x term here and an x term here, this was a squared term, so they couldn't combine, and it left us in a little bit of a lurch when we were trying to solve for x. So instead we said, well, if we subtract the 2 here and subtract the 2 here, what we do is we create an equation that is equal to 0. 126 equals 0. We then took out the greatest common factor. So if I divide each term by 2, plus 63 equals 0. And then we said, well, let's backwards FOIL this, because if we can create a product that equals 0, then we know that one of those pieces must be equal to 0. So if we do x and x, we look at multiples of 63, so things that multiply to 63 for that last term. That would be something like 7 and 9. Everything is positive, so we get 7 and 9. Okay, so x is equal to -7, because that makes that piece 0, or x is equal to a -9, so we can solve by factoring. When there was no middle term, so notice this one has a b value, this one does not, right? Then it's easy to get x by itself, and all we have to do is use square roots. So if we go ahead and solve this one, number 3, we would add 5 to both sides, trying to isolate the squared term. We then go ahead and divide by 100. X squared is equal to 1/4. And to get rid of the squared, we square root, which means we square root both sides, and we make sure that we remember that there's a positive and a negative possible solution here. And remember, the square root of a fraction is just the square root of the top over the square root of the bottom. So the square root of 1 is 1, the square root of 4 is 2. So x is equal to a positive or -1/2. Okay. The third way to solve is by completing this square. Now in class we already went over this strategy, and we used this strategy when we were writing the equations in vertex form, so those of you that already feel comfortable with this would not need to refresh maybe on this video. But again, we talked about if I want to take it from standard form and put it into vertex form, the reason that we would do that is 1, to help us find the vertex, or 2, because this one is a little bit easier to solve, right? There's only that one little x piece. We practiced solving this in the last lesson. So when we solve, we say, well, when is x, what are the solutions of x when y is 0? And it allows us to solve this one pretty simply by just moving that c or the k value over to the left, square rooting both sides, and solving there. So if you need to be reminded of these steps, I'm going to step to the next example, but there's one there. Here in this example, in this box, remember that when it's in standard form, it's not always nice and factorable. So we move the 45 off to the right-hand side, and we create a factorable trinomial. Before we do that, we always make sure we pull out the a value. So notice they divided a 2 out of this term and this term, leaving x squared minus 10x. Okay. Now again, we left this open space so that we could create a number that would allow us to factor this down into something that looked identical, so that we could write it as a perfect square. Okay, and the way that we do that is we always take half of this. When we know what we want to factor it to, then it helps us choose that number. So we want this to end up with x minus 5 and x minus 5, because that gives us that -10 in the middle. And remember, if you were looking at this, last times last, or -5 times -5, is a positive 25. So that's essentially how we're coming up with that number. The way we talked about it in class, just quickly, is we always take half the middle term and square it, and that gives us that value there. And then remember, you just added a value to the equation, so you've got to keep it balanced. So you're going to go ahead and multiply it by 2, or think about when I put the 25 there, I've really added 50 to this equation, because 2 times 25 is 50. So you'll notice on the end, to balance that out right here, they've subtracted 50. Okay. Again, the 2 stays out front. We can go ahead and factor this. We combine 45 and negative 50 to get negative 5. And in the end, we end up with our vertex form there. Now again, how does that help us? Well, it allows us to solve because we know how to kind of work with that at that point. So that's what I'm going to kind of look at as I go here. And again, this is super weird maybe, but I'm just going to cross out example 4. Again, we did these already. I just want to show you now how we would solve this. So solutions occur again when y is equal to 0. So I'm going to let y equal 0. And then this is like last time's assignment. So you would add the 5 to both sides because we're trying to get the squared piece by itself. So we get 2, we get x minus 5 squared. We then want to get rid of the 2, so we divide by 2. So over here I have 5 halves is equal to x minus 5 quantity squared. To get rid of the square root, the squared, we square root this side. And if we square root one side, we must square root the other side and not forget the 2 possible solutions. From there, on this right side, we got rid of that square root, so we have x minus 5. And on the left side, we have plus or minus the square root of 5 over 2. Remember, when you have the square root of a fraction, it's the square root of the top over the square root of the bottom. I'm going to rationalize that in just a minute, but again, if I'm solving for x, I want to add the 5 over, so I want to get rid of that. So I'm going to write this up here. That leaves me with just x on this side, and it leaves me with 5 plus or minus the square root of 5 over the square root of 2. Oops. That would be our final answer. However, we don't like to leave radicals in the bottom, so remember to rationalize or get rid of a radical there. We multiply him by himself. So when we do this, we end up with 5 out front, plus or minus, if I do the radical of 5 and multiply it by square root of 2, that's square root of 10, all over the square root of 2 times the square root of 2 is the square root of 4, which is 2. So this would represent our final answers for this. And again, we could approximate these if we wanted to. We would just put in 5 plus square root of 10 over 2 and 5 minus the square root of 10 over 2. Now remember, we can't simplify this any further, right? Because 10 is inside the radical and 2 is on the outside. Okay. Let's go through just one more of these. Sorry, I'm going to do example 3 off to the left, and I will start by completing the square, and then I will solve. So if we're looking at this one, again, I'm just going to let it equal 0 because we know that we are solving. So when we are completing the square, we move the 5 out of the way, so we've got 0 equals 2x squared plus 12x minus 5. Now you actually, because you know that you're solving, you could actually move this 5 to the other side of the equation if you wanted. You could just add it at this point, add 5 to both sides. Maybe let's do that just to show you kind of the difference here. Oh, let's go here. So I get 2x squared plus 12x, and remember we want to factor out that 2, so we get x squared plus 6x, and I'm going to leave some room there. Now, again, if I want to find this perfect number, I take half of 6, which is 3. I square that, and then I end up with 9 there. But remember, when you add that 9 in, you really added 2 times 9, which is 18. So to keep this equation balanced, I'm going to subtract 18 out here. Or in other words, if I'm putting a negative 18 out there, right, we could just keep this balanced by adding 18 to the other side. So let's do that. We get 23 is equal to 2 x squared plus 6x plus 9. Then we keep solving here. Again, we're just completing the square. So we've got x plus 3. I'm going to write out every step. We could skip a few here. We get 23 is equal to 2 x plus 3 quantity squared. We could divide by 2. And we get 23 over 2 is equal to x plus 3 squared. So at this point, we're going to square root like we did the other, right? Because we want to get rid of the squared, so we get x plus 3. And don't forget your plus or minus. And this is another one of those plus or minus square root of 23 over the square root of 2. We don't like the radical in the bottom, so we would rationalize that. I'm running out of room. Alright, really messy, but it's coming up here. So on the top I have the square root of 23 times the square root of 2, which is the square root of 46, and that won't simplify at all. And on the bottom I have the square root of 2 times itself, which just leaves the 2 in there. Okay, and that is still equal to our x plus 3, so our final thing there would be to subtract this 3 over. So our answer here is negative 3 plus or minus the square root of 46 over 2 is equal to x. Now this is as crazy really as those can get. You just have fraction values involved. Otherwise they'll simplify very nicely and we can just write their answer in its most simplified form. But again, coming back to completing the square, it puts it into vertex form, which is easier to solve because then you can square root both sides. So we practiced this techniques previously. If you need review, hopefully that gave you a little bit of review, and then you can look back at these boxes to kind of walk you through those steps.